session, and we
Hello.
will. Hello.
Hello, I can hear you.
Yeah.
Can you hear me?
Yes. Yes.
Please go ahead.
Okay. So, thank you very much for your kind introduction, and so we are going to run a session of this conference. So the first speaker will be Chong James Park. So he's chairman of Kukdo Chemicals and the Korean Carbon Nano Industry Association. So he has very vast experience on chemicals, and he will introduce us on bio source resins for epoxies. So please, Kukdo, you can start with your presentation.
Thank you. Today I'm going to introduce the new epoxy resin for future sustainabilities. I prepared a lot of pages, so some pages I have to quickly pass. And if you have any questions, you can contact me after the presentation. But some of pages are more focused, especially for bio subject. The contents, I will talk about the e-mobility in the fourth industrial revolutions. Secondly, if we talk about e-mobility, we have to prepare electricity first. And then, for example, like a car, it contains a lot of electronics and all other outer structures, everything. So first of all, I will explain about the renewable energies, which is a lot of demands for carbon composite as well. And then we will talk about the epoxy resin and hardener for composite. And then finally, I'll focus on this bio-epoxy resin for future sustainabilities. Actually, I'm in charge of vice chairman of Kukdo Chemical, which is one of the biggest in the world as epoxy manufacturers. We were established in 1972, and we have 4 factories in Korea and 2 factories in China, 1 factory in India. So let's see some small video introductions. I cannot hear any sounds. It should be. Yeah, we have factory in Korea, 4 different places, and 2 factories in China, 1 in India. Business segment is mainly for epoxy resins, most cases, and curing agents. And we also manufacturing raw material for special chemistries and polyurethane and polyol. And then we have a business as composite materials. Total sales about 10% belong to these composite materials. Oh, sorry. Also, this JEC Korea, we are organizing cooperate with JEC Korea, and from 3rd November we are doing the first Carbon Korea 2021, and I'm also in charge of chairman of this we call KCANIA, Korea Carbon Nano Industry Association, And we have now members, 57 company, who are demanding company and materials company and component equipment companies. So we founded last year, September, and then we are doing the business. This is a main project at the moment. We are doing some kind of strategic research and survey and support the companies and manpower training, international cooperations, and especially right now we are doing some, this is what we are doing, Carbon Convergence Alliance. So we select core demand industries and core promising items. And then we, according to the government policies, we prepare this kind of the work group, and we hardly work together to make some progress. And we are going to have some reports next week. So after fourth industrial revolutions, the raw material manufacturers, as raw material manufacturers, we can see because of this, the IoT or factory automations, and all the industries, including energy industries, we have to consider about the high-speed mass production, and then also lightweights and fuel efficiencies. And then we will discuss today green sustainabilities for the futures. As resin manufacturers, we are preparing of this high-speed, high frequencies, high integrated circumstance. And also the productions is now not only the few mass production, we are doing the diversify production, small specialty manufacturing. So we are doing the all related materials like a low decay, low correspondence epoxy resins, high purities, 3D printing resins. And then we are also developing new resin system for high performance to make lightweighting and high performance of the fast curing to make low energies, and then eco-friendly resins. Today we will discuss about the bio-green technologies. I don't need to explain about this, the problem now, global warming make climate changing. So every countries make neutrality of carbon dioxide. I like these diagrams. We have to protect or prevent the pollutions. And then we are now developing some new system for eco-friendly. But we have to prepare also about the recycling and upcycling as well. And this is Korean carbon fiber, carbon composite supply chains. Korea is very special country. We have carbon fibers, and we have resins. Some are plastic and some are set. And we have a lot of business. Automotive area is so number 5 in the world, and shipbuilding number 1, and electronics also number 1. So all related business is very fundamentally good funding, but we have some difficulty for this composite market in Korea. Raw materials we have a lot, but equipment and prepreg, we have several quite good prepreg, but they are not global players. So still a lot of area we are importing prepreg from overseas, like global number 1, Toray, Hexel, Solvay. We are importing for aerospaces and some recently like hydrogen tanks and the composite for electric vehicle. We still import things, a lot of prepreg. This is aerospace's supply chain. There are fiber manufacturers, prepreg, and we have an offset program in Korea from Boeing or Airbuses. So we have a manufacturer of aerospaces. And then we have a lot of good institutes, academy, from the strong support from governments. So we are doing KFX subject projects now. So all together, we are working together to develop a Korean-made fighter. Now, to make the e-mobilities, we have to have electricity. Now in Korea, we have a lot of renewable energies, especially solar energies, and also recently government strongly supporting of wind energies. So also Kukdo supplying to global #1 and second like Vestas, Siemens wind blade. And its blade is made by the now glass fiber or carbon fiber, and there is onshore and offshore. So this is the Korean wind power situation. If you can see, 2016 it was 7% of our total electric power. It was renewable energies. Governments made the policies we call renewable energy 30-20 policies. So by 2030, they want to increase the renewable energy up to 20%. So it means 63 gigawatt. On this 63.8 gigawatts, wind power will be about 28%. It means 17.7 gigawatts. So by 2030, our government wants to have 63.8 gigawatts renewable energies. On that, the wind power, the target is 17.7 gigawatts. It's 28% of total renewable energies. So it means, according to government target schedule, we have to install every year 1.6 gigawatts. It's quite big. I think almost impossible, but government has strong driven, so we are working on that. And this is the some project we already done with some Korean company. Tucson is they are doing the business of wind turbine. So it was the 5.5 megawatts, 8 megawatts. And then this kind of 8 megawatt or 10 megawatt for offshore, its length is about 100 meters. So to prevent and distortion of any accidents, they are using some carbon pollution spar cap in the middle. So these projects, according to the government's projects, for this 8 megawatts, they are going to have more than 100 megawatts in southern part of Korea. We calculate how much they need of this carbon pollution bar. It's about 5.1 kilometers. It's huge. So demands of carbon fiber is big, and also for this wind blade, using a lot of epoxies. One blade using more than 2 containers of epoxies. So we have to prepare epoxy resin and glass fiber and carbon fiber. The problem is carbon fiber is being used for this offshore blade, especially globally. China market is more than 50% in global demands. So China, they are absorbing, importing a lot from carbon fiber manufacturing in the world. Now we are facing with carbon fiber shortage problems. This is some process of there. And then we have to do from the renewable energies or some power plant, we have to send like a grid. On this one, high voltage cable needs some core inside. Now the new, because of this long distance, because of the weight of the cable, they have to install not far distance. So now they are changing of this cable with carbon fiber core inside. So in Korea, some of companies are developing of this kind of epoxy carbon protrusion cable core. So it's also sustainability. We are preparing of this power system, and then we need to have some transformer, electric distributions. All of this, the machine and facilities are using a lot of encapsulation and insulation of epoxies. And then, for example, electric vehicle also inside now, instead of the engine, they are doing the motor. So this motor, driving motors are using a lot of encapsulation and molding compounds. So it's also epoxies we are preparing. And then the electric vehicle using a lot of electronic, the software and some semiconductor. So now semiconductor for vehicle is shortage. And then we also developed manufacturing and developed for this kind of encapsulations, the resins for that. And then because of this electric vehicle using a lot of digital programs, and then we have to prepare about EMI shielding. Otherwise, unmanned driving car, it will have some trouble. Now, actually, I prepared many pages for epoxy resin chemistries, but you can have it if you need more. I can send you later on. For epoxy compounds, epoxy composites, usually we are supplying a BPA-based one. I have no points here, but normally, most cases, more than 85%, they are using BPA-based epoxies. And then recently, to make lightweight composites, they are using low viscosity BIS-F type. And then some prepreg, they are using semi-solid BPA grade. And others, some the frame retardants, we have a brominate or non-halogen system as well. And also for composites for automobile, it should have toughens, like on the coats is anti-chip, or it's driving, it has a lot of vibration. So we have a flexible system, toughened systems, and heat resistance also important. And glycerylamine for low temperature fast cure, we are supplying glycerylamine type resins. And then recently we are doing a lot of work with the composite manufacturer, bio-based one. We have several steps, so today we will explain more detail. And then epoxy resin needs requiring curatives, curing agents. We are supplying all kind of resins. So amine-based one, anhydride-based one, and then we need to do sustainability, also bio-based curing agents. This is the classification of curing agents for epoxy resins. I will skip of this one. It depends on the process. They are curing at like a room temperature or medium temperature, high temperature. Depends on the requirement. This is what we can see for automobile. I think in the futures, even they can change it to composite, regardless of this some plastic or some setting. It's too expensive to replace of steel. So in most cases, they will use steel parts with composite. So, for example, now the industries already developed and making supply for primary structure like floor and roof or food and trunk reeds. They are replaced for lightweight carbon composite, but generally for the cars, you can see the electrodeposit coating in the back. Normally the car, they are using like 5, 10 years or 20 years. So for anti-corrosion, they apply electrodeposit coating based on epoxies. And then most cars has a lot of the electronic components in there. So encapsulation also using epoxies. And for electric car, powertrain components using the encapsulation insulations with epoxies. And also the battery, the case of battery also based on the epoxy composite. And then the structural adhesives also based on epoxies. So many part of that, we are using a lot of epoxies. And then also in many places, many parts using a lot of some plastic and some sand. Now in interior side and also like a handle or many parts of that, lights and dashboard, they're using mainly with some plastics. This is showing what's epoxy composites for electric vehicle or fuel cell electric vehicle. So now you can see outside exhibition hydrogen fuel tanks. Hydrogen car is a big issue, and they are requiring of this hydrogen tank based on epoxy filament winding process. And then lightweight materials for many parts of that, we are already in the markets. We can see reactor motors. We have the adhesives and also laminating adhesives and compounding. And the converter inverter also needs some insulation, encapsulation of that. So based on epoxies. This is showing what kind of lightweights for automotive, like roof side and trunk reed, food and floor, and the ABC filler, and seat cross member, and lightweighting automotive. Also for commercial vehicle and passenger car, we have some suspension spring or rip spring also based on the composite. Side show battery pack and central floor side. You can see outside some Kukdo booth, there is some component there based on the carbon composite prepreg and HPRTM process.
Mr.
This is
Chong,
showing
5 minutes. 5 minutes left. Okay.
Oh, sorry. Yeah, time is running so fast. I will focus on this. Let's see. This is the what's considerable factor for different process, different applications. This is showing some example for a passenger car. Some part of there consists with epoxy compounds, making about 30% reduction of weight. Let's see bio-oriented epoxy system. Now, we say partly bio system based on the epichlorohydrin based on glycerin, we call epicerol. Epicerol-based epoxy, we can make it like a 27% bio contents in the BPA type, or 30% bio content BPF types. And then we have 100% bio-oriented epoxies on the cardinal-based one, sorbitol-based one, and 1,4-butanediol, 1,6-hexanediol, and then glycerol-based one, isosulfide-based one. And this is the experimental products. You can see what's bio-based one, we can use it for composite. As you can see, the mechanical property of the cured can be repasteable, like means they can get quite similar mechanical properties with bio-epoxies. And TG and tensile strengths, they can see quite similar one. I want to show you some other pages. This kind of isosulfide bio-epoxies, in case of this one, also TG, normally bio-based one has lower TG, but this one, you can have more than 100 TGs with good enough modulus and mechanical properties. So in the market, what they are doing, they are using 100% bio-epoxies and some the partly bio-epoxies mixed together to have optimizing mechanical properties and bio-content. So they can do it like 51% total, or they can do it 40%. This is the result of there. So this is the bio products we have. This is showing, it was JEC show, one of the French companies made canoe based on the bio-composite bio-epoxies. This is 100% bio-composite based on bio-epoxy and natural fibers. And also for energies, this is Siemens. They have a target recyclable the wind blades. So we also preparing sustainable epoxies to meet this requirement. So goal of bio-based epoxies, high performance bio-based epoxies, and maximum bio-contents. We call final goal is 100%. And then highly functional materials. So this is our roadmap. Up to 2025, we want to make it bio 100% material with high performance epoxy resin. This is subjects for sustainability. Actually, we can see a lot of area now they are making epoxy composite based on carbon fiber. But for example, like electric vehicle, we have to develop repairing technologies. And also we have developed recycling, upcycling technologies. Otherwise, people changing easily, not because of crashing. People changing the car, boring, want to find a new model. So we have to develop the recycling, upcycling technology.
Time is out.
Okay.
Okay. So please close the finish. So please just make the finish of the presentation, and so we can jump to the next one.
Okay. Thank you for your attention. If you have any questions, please contact us. We have some mailing address there. So this presentation you can share. I gave my presentation file to them. You can have PDF file with more details. Thank you.
Okay, so thank you very much.